Assalamu alaikum. I will talk today about polymer processing and rheology. This is a term project of applied polymer rheology, chemistry 540. As an outline, I will go through an introduction, then a background information of polymer rheology, some generalized viscosity model, rheology of felt polymers, polymer melt processing, and then I will finalize with multiple choice questions. Synthetic polymers may be classified into two main categories, thermoplastics and thermosets. Thermoplastic can be melted, heated, shaped by flowing through dies or filling molds and subsequently solidified into final useful product, while thermosets can be hardened by applying heat or pressure. This chapter is only discussing the thermoplastic processing, not thermosets. Usually during production for thermoplastics, they are blended with other material to produce pellets or powder or flakes for easier subsequent operation. These blended compounds may consist of fillers, colorants, other polymers, flame retardants, UV protection, reinforcements, stabilizers, and various processing aids. These additives have adverse effect on the polymer rheology, which will be discussed in this presentation. Viscosity is the resistance of a material to flow, shearing, based on Newton's law. And the law says viscosity equals shear stress divided by the shear rate. This relation is used to measure viscosity in Pascal second in SI units, which is equals to 10 poise. When the viscosity is independent of the shear rate, a fluid is called Newtonian. However, molten polymers have viscosities dependent on shear rate as well. This exhibits several other unusual flow properties and are referred as non-Newtonian shear thinning behavior, which is also known as pseudoplastic behavior. As the shear rate increases, the viscosity decreases. This is a diagram showing Hooke's spring and how it is stable, or it is having an increase of strain with increase of stress, and the slope is identified as the E, or Young's modulus. On the other hand, Newtonian dash pot is showing that when strain is increased, the stress is stable or fixed, it does not change, while the polymer has two behaviors, or it is joining both behaviors. So the pseudoplastic behavior represents both elastic and viscous, therefore it is called a viscoelastic fluid. Generalized models. There are multiple generalized models to identify pseudoplastics. The most commonly used is the power law model, which is identified by viscosity equals K, which is a fixed constant, times shear stress to the power n minus 1. This expression is a straight line when plotted on a double logarithmic coordinates. This graph here showing the Newtonian and shear thinning viscosity behavior when it is plotted with shear rate and viscosity. Rheology of filled polymers. Rigid particles are added to polymers either to improve the mechanical properties, reinforcements, or to reduce the cost as a filler in weight fraction up to 70%. Sometimes there might be both improvement of properties and cost reduction. Calcium carbonate, for example, is a frequently used filler. Talc is added to increase stiffness and high temperature creep resistance. Rubber is added to some thermoplastic to increase the impact strength. Carbon black, glass fiber, wood flour, and other natural fibers are also used in a variety of applications. Einstein resolved the problem of resistance to shearing caused by spheres of neutral density, and he showed that the viscosity of the suspensions is related to the viscosity of the matrix. And this is the model, or the equation, where theta is the volume fraction. This relation valid for concentration of fractions 0.01 or below. However, in very dilute solutions, particles will rotate due to the action of the shear field. As the concentration is increased, hydrodynamic interaction between the particles become more important. Now let's discuss polymer melt processing. There are various ways to process the polymer melt. The most important is extrusion. Extrusion is involving heat of polymer until it is melted, then adding your additives, whether it is solid or liquid, then pumping it through a screw until you reach your pelletizer. Sometimes the pelletizer is producing solids like pellets, and they are delicately shaped and involving cutting, cooling, and solidification. Extrusion of polymer melts with additives are done in screws where shearing occurs in thin gaps, while the extremely high viscosity molten polymer cause high shear rates. Therefore, screw design is very important to achieve high output rates of homogeneous high quality melt without solid particles, unmelts. This diagram shows a typical schematic diagram of a single screw extruder. There are single and double screw extruders designs also shown in our references. Second way of polymer melt processing is calendering, which is widely used for continuous process that involves a pair or more of counter-rotating heated calendars or rolls, as shown in this diagram. The feed of molten polymer is processed through the two rolls, and the film or sheet is produced out from it. This is used for production of thin plastic sheets and films. The thermoplastic melt is fed behind the minimum gap of the two calendars, as shown in this figure. The rotation movement forces the material to flow in the machine direction downstream and the lateral direction, with subsequent detachment from the rollers surfaces at the specific thickness. Two rolls calendering lines are usually used for rubbing processing, whereas 4-roll calendars are generally used for the production of double-coated products meeting strict surface. The third way of polymer melt processing is injection molding. It is a two-step cyclic process. First, melt generation by a rotating screw, and then secondly, filling of the mold with molten polymer by the forward ramming of the screw, called a reciprocating screw, followed by a very short packing stage necessary to pack more polymer in the mold to offset the shrinkage after cooling and solidification. The material is held in the mold under high pressure until it is solidified sufficiently to allow ejection. Injection molding machines vary in clamping capacity from few tons to thousands of tons. Also, the cycle time usually range from seconds to over a minute. Many products are produced from this type of polymer melt processing, such as boat hulls, plastic chairs, house appliances, and bottle caps. Very high shear rates arise in injection molding operation, usually up to 10 to the power 4 second per second. And to limit temperature increases from viscous heating and to facilitate easy filling, low viscosity thermoplastic polymer grades are used. Other techniques include compression molding. This is a very old technique that was used for thermosets via compression of molten polymer into high pressure hydraulic press. However, there are newer techniques that have replaced this technology, such as injection molding. Blow molding. This is a process where air is used to inflate a molten polymer to inflate a mold after injecting molten polymer, filling a cavity with predetermined shape and dimensions, which is called a mold. This technique uses extruded molten polymer to push it through a tube until it takes the exact dimensions of the mold. Cooling is usually done with air, and it is used to set the plastic in its final shape. One example is polyethylene terephthalate, or PET, which is a polymer most widely used for injection blow molding for carbonated soft drinks and water bottles. Now let's go for the multiple choice quiz. How does the viscosity of polymer melts behave? As the shear rate increases, the viscosity decreases. As the shear rate increases, the viscosity increases. As the shear rate decreases, the viscosity decreases. Viscosity is independent of shear rate. The correct answer is number 1. Question 2. Polymer melt processing is called calendering. Is used to produce what type of plastic? 3D printed artificial arms, underground water tanks, vehicular gasoline tanks, plastic sheets and films. The correct answer is plastic sheet and films. Third question, what is the most widely used polymer in injection blow molding for carbonated drinks and water bottles? PVC, ABS, PET, or polycarbonate? The correct answer is PET. This is it for this presentation. Thank you very much.